Alright guys, welcome back to another video. Today we'll be tackling binomial theorem. I've compiled these 3 questions. And without further ado, let's get started with question number 1. Alright, so the x-independent term in the expansion of that is 81 times the x-independent term in the expansion of the other expression. Right, and they want us to find n. Alright, here they make it really obvious that x-independent terms means like the term without any x in it. But they usually do not do this in exams, right? So usually be aware that in exams, if they say that it's the independent term, that means the term has no x in it, or like it's like a constant, right? And it's the most common when they have a fraction, right? Because if you realize in a fraction, like the first term or like the second term is a fraction, right? It's because like you can then cancel out the powers, right? Okay, well, let's see. Alright. Notice that actually in both expressions, the first term itself is the x-independent term, right? The first term itself is the x-independent term. So if we have here 2n plus 1 and c0, and then we have 3 to the power of 2n plus 1 is equals to 81 times 3 to the power of n. Right? Notice that I don't write n c0 anymore, because actually this one is actually equal to 1. Right, that's why I don't repeat it anymore. So yeah, here we have 3n, 3 to the power of 2n plus 1 is equals to 81 times 3 to the power of n. Right, and notice that 81 itself is 3 to the power of 4. Right, so we have 3 to the power of 2n plus 1 is equals to 3 to the power of 4 times 3 to the power of n, which is 3 to the power of 4 plus n. Right, so we have 4 plus n is equals to 2n plus 1. Therefore, n is equals to 3. Alright, so the first question is pretty self-explanatory, I guess, but like I just want, like, a lot of times like students are not accustomed to the fact that this type of questions, like the independent term, can be in expressions without like the fraction, because like, that's the one that they're most used to, right? And yeah, some students even resort to like writing out like the full expansion itself, like writing it really long, and just to realize that the first term is actually the independent term, right? So yeah, be careful with these expressions and like keep an eye peeled, alright? Because I actually like this might be like what, a 4-mark question, and it's actually like this simple. It's just like the understanding behind it is required. Okay, so yeah, let's move on with question number 2. Alright, so we have this expansion right here, and they give us clues about the fifth term and the coefficient of x squared. Okay, so the first thing to realize here is like the fifth term, which is 1120, is the x-independent term, right? Because it has no x there, has no x squared, x cubed, or whatever. And yeah, this is usually the common model where like you have a fraction like ax plus b over 3x, because like let's just say ax to the power of 4 over b over 3x to the power of 4, and then that means that the powers of x will cancel out. That's the type of question that usually students are used to, and that's why I put question number 1 there. And yeah, so since the fifth term is 1120, right? Since the fifth term is 1120, that means we have nc4, right? Because notice that nc0 is the first term, right? So it's always like the bottom number is always n minus 1, so the fifth term is nc4, right? And so we have here ax to the power of n minus 4 over b over 3x to the power of 4, right? But then computing this will actually be like a waste of time, because we're not trying to calculate the coefficient here like in such a manner, because we already have the information that the fifth term is 1120 and this one is actually the x-independent term. But even 1120 here does not help us. Like, it does help us if you like really want to calculate it, but we actually have a much easier way to calculate it, right? Because if you realize x to the power of n minus 4, and if we times it with x to the power of negative 4, that should give us x to the power of 0, right? That should give us x to the power of 0, because it's the independent term. This is why I mean that we actually do not need to find the coefficient. Like, finding the coefficient is not needed, although it is given to be 1120. The information is there to let us know that it is the independent term, right? So if we have this, so we have x to the power of n minus 4 times by x to the power of negative 4, that should give us x to the power of 0, or in other words, that's 1, right? is equals to 1, but if we want to find n, that means we have to convert it to x to the power of 0, so we have the common base, right? So right here we have n minus 4, and then plus negative 4 is equals to 0, right? And therefore, n is equals to 8. Okay, moving swiftly along to like the second part. Okay, so we already know that the n is 8. So right now we can use the information about the coefficient and find a and b. So right here we have 8c4 multiplied into ax to the power of 4 and b over 3x to the power of 4. That should give us 120, right? And let me just quickly calculate it. Okay, so 0.864 a to the power of 4 and b to the power of 4 is equals to 120, right? So a to the power of 4 into b to the power of 4 is equals to 1296. And therefore, if we just get a times b, and so we root this to the fourth, so we have 6. So AB is equals to 6, right? And we're given the second information here where the coefficient of x squared is 1792, right? And if here, this is where like a bit of logic is required, right? So we want to get x squared, and the n that we have, the highest n that we have is 8. Therefore, what combination do we need in order to give us x squared? Right? So if you realize x to the power of 5 times 1 over x cubed is equals to x squared itself, and 5 plus 3 is equals to 8. So it meets the criteria that we're supposed to achieve, right? And so with that being said, we can have 8c3, right, times ax to the power of 5 over b over 3x cubed is equals to 1792, right? And so we have, let me just quickly calculate that. So we have 56 a to the power of 5 b cubed over, I'm just getting rid of the x here already because like we know that that is, well, we're just trying to find the coefficient. Right, so this is actually 1792 x squared, but I don't write it down anymore. So we have 3 cubed, which is 27, is equals to 1792. So we have a to the power of 5 b cubed is equals to 864. Alright, let's see what we can do from here. So we have a to the power of 5 times b cubed equals to 864. So if we just have a squared and we have ab cubed is equals to 864. And notice that ab is equals to 6. So 6 cubed times a squared is equals to 864. Therefore, we can find a. So 864 divided to 216 and square root of that is 2. So a is plus minus 2, right? But notice here that it is given as a requirement that a must be a positive constant. So therefore, negative 2 is rejected. So if a is equals to 2, therefore b is equals to 3. And yep, that is it for question number 2. Let's move on swiftly to question number 3. Moving on to question number 3. So yep, I think this is the most challenging one because it involves a lot of simplifying and expanding. So yeah, we're given the coefficients of x cubed and x to the power of 4, and they are in the ratio of 3 over 2, right? So let's just get started. So we have nc3 into 3 to the power of n minus 3 times x cubed, and we have nc4 and 3 to the power of n minus 4 x to the power of 4, and this one is equal to 3 over 2, right? I'll get rid of the x here, like both x cubed and x to the power of 4, because we're only dealing with coefficients. And remember that nc3 can be expanded just as nc4 can, right? So we have n factorial over n minus 3 factorial and then 3 factorial multiplied into 3 to the power of n minus 3, and then we have another one which is n factorial over n minus 4 factorial, and then we have 4 factorial here, and 3 to the power of n minus 4, and the entire thing is equal to 3 over 2. Right? There's actually a division line here, right? But I just did not write it down just for the sake of cleanliness. Yeah, just remember that because like we're dealing with ratios after all. And with that being said, remember that n factorial here we can actually cancel it out with the n minus 3 factorial at the bottom, because n factorial will be n times n minus 1 times n minus 2 and times n minus 3 factorial. Therefore we can cancel out the n minus 3 factorial and the bottom one, just as we can do it with the n minus 4 factorial. Wait, sorry, I forgot to put a factorial here, right? So n times n minus 1 times n minus 2. So that's what we will have, because n minus 3 factorial will be cancelled out. So we have n into n minus 1 and into n minus 2 over 3 factorial times 3 to the power of n minus 3. In the meantime, let me just not write the ratio down. So we have here, we have n into n minus 1 into n minus 2 to n minus 3 over 4 factorial, right? It's up to n minus 3 because the next term will be n minus 4 factorial, and that will be cancelled with the denominator. And so right now we will have times 3 to the power of n minus 4, right? Right, so let me just quickly erase this part. Right, okay, notice that the n into n minus 1 into n minus 2 can be cancelled out with the one in the bottom. So right now we have 3 to the power of n minus 3 over 3 factorial, and the bottom one we have n minus 3 into 3 to the power of n minus 4 and then over 4 factorial, right? And so let me write down the ratio again. This one is entirely equals to 3 over 2. Okay, let me just quickly oops. Okay, let me just quickly erase this part. Alright, so let's just do the division right now. So we have 3 to the power of n minus 3 over 3 factorial times, because when you divide you find the reciprocal, so we have 4 factorial over n minus 3 and 3 to the power of n minus 4. Right, notice that this can be further cancelled out to give us 4, because 4 factorial equals to 4 times 3 factorial, which is then cancelled. So we have 4 into 3 to the power of n minus 3 over n minus 3 into 3 to the power of n minus 4, right? Okay, so right now we need to do a bit of manipulation, where it gets a little bit tricky, right? So right now our goal will be to cancel out either 3 to the power of n minus 3 or 3 to the power of n minus 4, and I find that it's easier to cancel out 3 to the power of n minus 4 at the bottom, because like if you realize, like 3 to the power of n minus 4 is equals to 3 to the power of n minus 3, and then you get another minus 1, right? So technically speaking, we can actually cancel it out if we just play with the variables a little bit. So right now, if we have 4 into 3 to the power of n minus 4 and then into 3, right? Because this is actually the same, right? This is actually 3 to the power of n minus 3, right? Because n minus 4 and then 3 to the power of 1 and then plus 1, that is equal to 3 to the power of n minus 3. But we're only doing this to manipulate with the variables. So right now we have n minus 3 into 3 to the power of n minus 4, right? So right now we can cancel this out. So we have 4 times 3, which is 12. So let me just write it here. So we have 12 over n minus 3 is equals to 3 over 2, right? So we have 24 equals to 3n minus 9, right? So therefore, n is equals to 11. And yeah, that is it for like today's session. I hope you all enjoyed it, and yeah, I hope you guys tried the questions first before looking at the solution. That way the solutions stick better and you understand it better. And speaking of which, I've started like an IGCSE website about math and science, not with biology because I don't take biology. And yeah, just there, like there's tons of content that I think you will find really useful, like how to write good notes, how to revise, how to quote unquote hack the mark scheme, and so on and so forth. And yeah, with that being said, see you guys in the next one. Bye.